Hi everyone, I'm Eng Tiong Chia. Today I'm going to share about the machine learning landscape. What is machine learning? Machine learning is the science and art of programming computers so they can learn from data. Here is a slightly more general definition. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And a more engineering-oriented one, a computer program is said to learn from experience E with respect some task T and some performance measure P if the performance on T as measured by P improve with experience E. Why use machine learning? Consider how you would write a span filter traditional programming technique. First, you will look at what span typically look like. You might notice that some words or phrases such as for you, credit card, free and amazing tend to come up a lot in the subject. Perhaps you would also notice a few other patterns in the sender name, the email body, and so on. Second, you will write a detection algorithm for each of the patterns that you notice, and your program would flag email as spam if a number of these patterns are detected. Third, you will test your program and repeat step 1 and 2 until it's good and healthy. The traditional approach, since the problem is not trivial, the program will likely become a long list of complex rules, pretty hard to maintain. And according to if you're using a machine learning approach, a span filter based on machine learning technique automatically learns which word and phrase are good predictors of span by detecting unusually frequent pattern of words in the span example compared to the ham example. The program is much shorter, easier to maintain, and most likely more accurate. Moreover, if spammers all email containing for you are blocked, they will start writing for you instead. A spam filter using a traditional programming technique would need to update to flag for you emails. If spammer keep working around your spam filter, you will need keep writing a new rules forever. In contrast, a spam filter based on a machine learning technique automatically notice that for you has become unusually frequent spam flagged by user and it starts fetching them without your interventions. Machine learning can help humans learn. ML algorithm can be inspected to see what they have learned, although for some algorithms this can be tricky. For instance, the span filter has been trained on enhanced span, it can easily be inspected to reveal the list of words and combinations of words that it believes are the best predictors of span. Sometimes these will reveal unsuspected correlations or new trends and thereby lead to a better understanding of the problem. Applying machine learning technique to dig into large amount of data can help discover patterns that were not immediately apparent. This is called data mining. To summarize, machine learning is great for problem for which existing solutions require a lot of hand tunings or long list of rules. One machine learning algorithm can often simplify code and perform better complex problems for which there is no good solutions at all. Using a traditional approach, the best machine learning technique can find a solution. Frustrating environment, a machine learning system can help adapt to new data, getting an insight about complex problems and large amount of data. Type of machine learning system. There are so many different of machine learning systems that is useful to classify them in broad categories based on whether or not they are trained with human supervision, supervised, unsupervised, and semi-supervised and reinforced learning, whether or not they can learn incrementally on the fly, online versus batch learning. Third, they work by simply comparing a new data to no data point or instead detect patterns in the training data and build a predictive mode, much like scientists do. Instance-based versus model-based learning. These criteria are not exclusive. You can combine them in any way you like. For example, a state-of-art span filter may learn of fact using a deep neural network model trained using example of span and HAM. BISMAT is an online model-based supervised learning system. Supervised and unsupervised learning. Machine learning system can be classified according to the amount of and type of supervision they get during training. There are four major categories: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, the training data you feed the algorithm include the desired solution, call label. A typical supervised learning task is classification. The span filter is a good example of this. It is trained with many example email along with their class, and it must learn how to classify the new email. Another typical task to predict a target numeric value such as the price of a car given a set of features, mileage, age, brand, called predictor. This sort of task is called regression. To train the system, you need to give it many examples of cars including both their predictor and their labels. Here are some of the most important supervised learning algorithms: k-nearest neighbor, linear regression, logistic regression, support vector machine, decision tree, and random forest neural network. Unsupervised learning. In unsupervised learning, as you might guess, the training data is unlabeled. The system tries to learn without a teacher. Here are some of the most important unsupervised learning algorithms: clustering, k-mean, hierarchical cluster analysis, expectation maximization, visualization, and dimensionality reduction, PCA, kernel PCA, LLE, TSNE, association learning, April, and ECLAB. For examples, say you have a lot of data about your blog visitor. You may want to run a clustering algorithm to detect group of similar visitors. At no point do you tell the algorithm which group of visitors belong. It finds those connections without your help. For example, it might notice that 40% of your visitors are male who love comic books but generally read your blog in the evening, while 20% of the young Skill level who visit during a event, and so on. If you use hierarchical clustering algorithm, it may also subdivide each group into a smaller group. This may help you target a post for each group. Visualization algorithms are also a good example of unsupervised learning algorithm. You feed them a lot of complex unlabeled data, and they output a 2D or 3D representation of your data that can easily be plotted. These algorithms try to preserve mass structures as they can, trying to keep a separate cluster in the input space from overlapping in the visualization, so you can understand how the data organized and perhaps identify and suspected pattern. Another important unsupervised task is anomaly detection. For example, detect semi-supervised learning. Some of the algorithms can deal with partially labeled training data, usually a lot of unlabeled data and little bit of labeled data. This is called semi-supervised learning. Some photo hosting services such as Google Photo are examples of this. Once you upload your family photo to the service, it automatically recognizes that the same person will show up in a photo 1, 5, and 11, while another person B show up in a photo 2, 5, and 7. This is unsupervised part of algorithm clustering. Now all the system needs is for you to tell it who these people are. Just one label person per person, and it able to name everyone in every photo, which is useful for searching photo. Most semi-supervised learning algorithms are combinations of unsupervised and supervised algorithms. For example, deep belief network (DBNs) are based on unsupervised component called restricted Boltzmann machine (RBMS) stacked on top of one another. RBMs are trained sequentially in unsupervised manner, and then the whole system is fine-tuned using supervised learning technique. Reinforcement learning. Reinforcement is a very different beast. The learning system called agent in this context can observe the environment, select and perform actions and get rewards in return or penalties in the form of negative reward. It must learn by itself what is the best strategy called policy. To get the most reward over time, a policy define what actions the agent should choose when it's a given solution. For example, many robots implement reinforcement learning algorithm to learn how to walk. DeepMind AlphaGo program is also a good example of reinforcement learning. It made the headline in May 2017 when it beats the world champion Ke Jie at the game of Go. It's winning policy by analyzing millions of games and playing many games against itself. Notes that learning was turned off during the games against the champion. AlphaGo was applying a policy it had learned. Cache and online learning. Another criterion used to classify machine learning system is whether or not the system can learn incrementally from a stream of incoming data. In batch learning, the system is incapable of learning incrementally. It must be trained using all the available data. This will generally a lot of time and computing resources, so it's typically done offline. First, the system is trained, and then it launched into production and run without learning anymore. It just apply what is learned. This is called offline learning. Online learning, you train the system incrementally by feeding it data instance sequentially, either individually or small group of called mini batches. This learning step is fast and cheap, so the system can learn about new data on the fly as it arrives. Online learning. Online learning algorithm can also be used to train a system on a huge data set that cannot fit in one machine memory. This is called false learning. The algorithm looks part of the data, runs a training step on that data, and repeat the process until it has run all the data. Instant-based versus model-based learning. One or more ways to categorize machine learning system is by how they generalize. Most machine learning tasks are about making prediction. This means that given a number of training examples, the system needs to be able to generalize to examples has never been seen before. Having a good performance measure on the training data is good, but insufficient. The true goal to perform well on new instances. There are two main approaches for generalization: instant-based learning and model-based learning. For instance-based learning, instead of just fetching emails that are identical to no spam email, your spam filter could be programmed also fetch email that every similar no spam email that require measure of similarity between two emails. A very basic similarity measure between two emails could be count the number of words they give in common. The system would flag an email as spam if it had many words in common with no spam email. This is called instant-based learning. The system learns the example by heart, then generalize to a new case using similarity measure. Model-based. Another way to generalize from a set of examples to build a models of these examples. Then use that models to make prediction. This is called model-based learning. Machine learning. What is the main challenge of machine learning? Insufficient quantity of training data. For a total to learn what an apple is, all it takes is for you to put an apple, say apple, possibly repeating this procedure in a few times. Now, the child is able to recognize apples in all sorts of colors and shapes. Genius. Machine learning is not quite there yet. It takes a lot of data from most machine learning algorithms to work properly. Even for very simple problems, you typically need 1,000 of examples. And for complex problems such as image or speech recognition, you may need 1,000,000 examples unless you can reuse a part of our existing model. Non-representative training data. For example, the set of a country we used earlier for training linear model was not perfectly representative. A few countries were missing. If you train a linear model on this data, you will get solid 9. While the old models is represented by The dotted line, as you can see, not only adding a few missing country significantly alter the model, but it makes it clear that such a simple linear model is probably never going. It seems that very rich countries are not happier than moderately rich countries. In fact, the seem unhappier. And conversely, some poor countries seem happier than many rich countries. By using a non-representative training set data, we train the models that are likely to make accurate predictions, especially for a very poor and rich country. It is crucial to use a training representative of the cases you want to generalize to. It's often harder than it sounds. If the sample too small, you will sampling noise, no representative data as a result of chance. But even a very large samples of representative sampling method is effective. It's called sampling bias. Poor quality data. Obviously, if your training data is full of error, outlier, and noise due to poor quality measurement, it will make it harder for the system to detect underlying pattern, so your system is less likely to perform well. It is often worth the effort or spend time cleaning up your training data. For true, is most data scientists spend significant part of their time to doing just that. Irrelevant features, as the saying goes, garbage in, garbage out. A system will only be capable of learning if the training data contains enough relevant features and not too many irrelevant ones. A critical part of the success of a machine learning project is coming up with a good set of features trained on. Overfitting the training data. Say you are visiting a foreign country and taxi driver rip you off. You might tend to say that all taxi drivers in the country are thieves. Overgeneralization is something that we humans do all too often, and unfortunately machine can fall into the same trap if we are not careful. In the machine learning, it's called overfitting. It means that the model performs well on the training data but does not generalize well. Underfitting the training data. As you might guess, underfitting is the opposite of overfitting. It occurs when model is too simple to learn underlying structure of the data. For example, a linear model of live television is prone underfit. Reality is just a more complex than the model, so its predictions are bound to be inaccurate. Even on the training example, the main option to fit this problem are selecting a more powerful models with more parameters, fitting a better features to learning algorithm features engineering, reducing the constraints on the model. Example, reducing the regularization hyperparameter. Stepping back. Machine learning is a By now, you already know a lot about machine learning. However, we went through so many concepts that you may be feeling a little lost. Just one last important topic to cover. Once you have trained a model, you don't want to just hope it generates a new case. You want to evaluate it and fine-tune if necessary. Testing and validating. The only way to know how well the model will generalize to new cases is to actually try it out on new cases. One way to do that is to put your models in production and monitor how well it performs. This works well, but if your model is horribly bad, your user will complain not the best idea. A better option is to split your data into two sets, the training set and the test set. as these names imply. You train your model using a training set and you test using a test set. The error rate of a new case is called generalization error or out of sample error, and by evaluating your model on the test sets, you get an estimation of this error. This value tells you how well your model will perform on instances it has never seen before. If the training error is low, your models made a few mistakes on the training set, but generalization error is high. It means that your model overfitting the training data. So, evaluating a model is simple enough. Just use a test set. Now suppose you hesitating between the two models, say a linear model or polynomial model. How can you decide? One option is to train both and compare how well it generalizes using a test set. Thanks for listening my presentation. If you have any question, you can tweet me or view my blog. Here is the resources that I use for this presentation. Thank you.